Now we're going to do cubic graphs. So the cubic graphs are in the form of y is equal to ax cubed plus bx squared plus cx plus 9. Then the characteristics of cubic graphs, starting with the shape. If a is greater than 0, that means if a is positive, this is the shape of the graph that we are going to have. As you can see with the cubic graphs, we've got two turning points, the maximum turning point and also the minimum turning point. Again, if a is less than 0, that means if a is negative, then this is the shape of the graph we're going to have. Okay, for an example, sketch the graph of y is equal to x cubed minus 6x squared plus 9x. If you want to study more about this, the cubic graphs, you can turn to page 186 from your N3 textbook. Okay, but this example is not from your textbook. The one that I'm using is from another source. Okay, the steps to follow for us to sketch the graph. Firstly, we must start with the y-intercept. Y-intercept, we let x be 0. What does that mean? It means in place of x, whenever you see an x, you put a 0. Whenever you see x, you put a 0. So you're going to have 0 to the power 3 minus 6 of 0 squared plus 9 times 0. Then you use your calculator, therefore y is equal to 0. What does that mean? When x is equal to 0, the value of y is equal to 0. So this is a point that we are going to have when we plot a graph. Second step, you must calculate the x-intercept. X-intercept, you let y be equal to 0. What does that mean? It means in place of y, you put a 0. So 0 is equal to x cubed minus 6x squared plus 9x. Then what do you notice with the first term, second term, and the third term? There's an x that is common. X is common. So x is the common factor. Then what is x cubed divided by x? The answer is x squared. What is negative 6x squared divided by x? The answer is negative 6x. What is 9x divided by x? The answer is 9. Okay, now next step, we can swap this. We'll start with x into x squared minus 6x plus 9. Then we put the 0 on the other side. What is this that we have done here? We just swap. You don't need to swap, but I'm just swapping so that you don't get confused when we're solving for x. So the 0 is here. Then now let's factorize what is inside the bracket. So we've got this x, that was the common factor. Then inside the bracket, x squared minus 6x plus 9. Then we want two numbers. When we multiply, they give us 9. The same numbers when we add, they give us negative 6. Then factors of 9 is 3 times 3. But now the middle term is negative. Okay, the middle term is negative. Let me use a bigger space because this space is not enough. Let me use the top part here. We want two numbers. When we multiply, they give us 9. The same numbers when we add, they give us negative 6. So the factors of 9 is 3 times 3. Then we must consider also the negative. Why? Because the middle term is negative. So it's negative 3 times negative 3. Also, another factor of 9 is 1 times 9. But we don't need to use that because you must consider this. The middle term is negative 6. Okay. So let's see which pair meet the requirements. There's 3 plus 3, like positive 3 and a positive 3. And also there's negative 3 and a negative 3. 3 plus 3, it gives us positive 6. Negative 3 and negative 3 give us negative 6. So this pair does not meet the requirements. So which pair meet the requirements? It's minus 3 and also minus 3. It means the other bracket is going to be x minus 3 and the other bracket will be x minus 3. Now let's solve for x. X is equal to 0, or x minus 3 is equal to 0, or x minus 3 is equal to 0. But what do you notice here? These x values are the same. So if they are the same, you don't need to write both of them. You can just take one. So you've got x is equal to 0, so the second x is equal to 3. So these are your values, x values. When we've got x is equal to 0 when y was equal to 0, and then we've got x is equal to 3 and our y was given as 0. Okay, so these are other points that we are going to have when we plot our graph. Third step, we must find the turning points. The turning points are made up of x and y values. Okay, so with this graph, we said the shape of this graph, if a is greater than 0, this is the shape of the graph that we are going to have. This is the shape of the graph that we are going to have, whereby there's a maximum turning point and also the minimum turning point. So how to find the turning points? Also, you can study more about this on page 189. You can start maybe from page 185. You will see how to find the turning points of the cubic graphs. So you are given y is equal to 1, x to the power 3 minus 6x squared plus 9x to the power 1. Why I put 1 here? Okay, because originally it was like this. Originally it was like y is equal to x cubed minus 6x squared plus 9x. But now, before we derive, we check first, is the function in a standard form of a differentiation? Because we are going to derive here. Okay, the answer is yes, it is in a form of a differentiation, but now there's an invisible one here that is not written, and also this 9x is the same as 9x to the power 1. Now let's derive. Y prime is equal to 1 times 3 x to the power 3 minus 1 minus 6 times 2 x to the power 2 minus 1 plus 9 times 1 x to the power 1 minus 1, which gives us, what is 1 times 3? 3x. 3 minus 1 is 2. Then what is 6 times 2 x to the power 2 minus 1 is 12x. Because 6 times 2 is 12. Then x to the power 2 minus 1 is 1. We don't need to write the 1. Then what is 9 times 1? It's 9. X to the power 1 minus 1 is to the power 0. Okay? So any number to the power 0, remember it was going to be like this, 9x to the power of 0. Then we all know that any number to the power 0 is 1. So what is 9 times 1? The answer is 9. So we're done with this. Then the second thing that we need to do after we have derived, for us to get the x coordinate of the turning point, we must let the derivative be equal to be equal to 0. That means y prime is equal to 0. Here is 0, and then we're going to solve for x. Then 0 is equal to 3x squared minus 12x plus 9. This is what we have. But what do you notice again? There's a common factor. If you can see 3, 12, 9, these are the multiples of 3, meaning that 3 is common here. How many 3 in 3x squared? The answer is x squared. How many 3 in negative 12x? The answer is 4x. How many 3 in 9? The answer is 3. So 0 is equal to x squared minus 4x plus 3. But if you don't see a common factor and you want to solve for x, and you've got a challenge on how to solve for x, you can use this formula, people. This formula, the quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. You can't lose these marks because you have an option of using a formula if you've got a challenge on how to factorize and solve for x. Okay, so we've got 0 is equal to x squared minus 4x plus 3, which you can swap as x squared minus 4x plus 3 is equal to 0. So what we did here, we swap, we didn't take it over. So there's no need for you to change the signs, because what we did is the same thing that we did initially, is to swap. Okay, Then what are the factors of x squared minus 4x plus 3? Again, we want two numbers. When you multiply, they give us positive 3. The same numbers when you add, they give us minus 4. The middle term, it's negative. It means we must consider a negative 3 and a negative 1. We don't have a space there. Okay, let me use another space. Swap. Then we can use this space on the other side. Oh, here. Let's use the bigger space. We want two numbers. When you multiply, they give us 3. The same numbers when you add, they give us negative 4. So, since the middle term is negative 4, it means the numbers that we need to consider are negative numbers, which is negative 3 and negative 1. Because negative 3 times negative 1, it gives us positive 3. And then negative 3 and negative 1, they give us this answer, negative 4. So what does that mean? It means we've got x minus 3 and x minus 1 is equal to 0. So these are our brackets or our factors. Okay, then we solve for x. X minus 3 is equal to 0. Therefore, x is equal to 3. X minus 1 is equal to 0. Therefore, x is equal to 1. So now let's move, because we don't want only the x values of the turning point, but we also want the y values of the turning point. Then, according to the method that we are using in cubic graphs, how to find the coordinates of the turning point, we must substitute x is equal to 3 and x is equal to 1 into the original equation. Original equation. So we're going to do step by step, starting with x is equal to 3. So y is equal to x cubed minus 6x squared plus 9x is our original equation. In place of x, we substitute 3. So we've got 3 all to the power of 3 minus 6 of 3 squared plus 9 times 3. Therefore, y is equal to 0. So what does that mean? It means the other turning point that we are going to have has got 0.3 is to 0. So this is a point. Okay, then we use x is equal to 1 because there were two x values. So we are done with x is equal to 3. Now we must go to x is equal to 1. X is equal to 1, y is equal to x cubed minus 6x squared plus 9x, 1 cubed minus 6 of 1 squared plus 9 of 1. Then the answer is 4. What does that mean? It means the another turning point that we're going to have, the value of x is 1, the value of y is 4. Then we've got all the points. Now let's plot the points on the graph. The graph is already done. So we were having these points 0 is to 0 for the y-intercept. Then we are having these points for the turning points, 1 is to 4, and also this point 3 is to 0 for the turning point. 0 is to 0, it was the points for the y-intercept. Again, it was the points for the x-intercept, like it was another point for the x-intercept. So this point covers two things. Ne? It was the point for the y-intercept, and also it was a point for the x-intercept. Okay, so same applies with this one. This one is a turning point, and also it was a point for the x-intercept. It was a point for the x-intercept, this one. So you just plot your points. After plotting your points, you know how the shape of the graph is going to look like. Then you join all the points. Okay, you join all the points, and then you get a graph like this. Then when we mark this point, we mark the maximum turning point and the minimum turning point, and also the shape of the graph. Thank you.